There's several different types of curves that you can create, and curves are generally meant to be for a sweep feature. The different ways that you can create a curve in SolidWorks are going to be a spline on surface, which actually allows you to sketch directly on a 3D face. So that's actually a sketch feature rather than a curve feature. An equation-driven curve where you'll enter in an equation and SolidWorks will create a curve feature for you. You got a curve through XYZ points where you enter in coordinates, and SolidWorks creates a curve that goes through those points. There's also one called curve through reference points, where you select points rather than specify them with coordinate. But the most popular ones, one of them is not on here, is going to be a helix or a spiral. Then the other most popular one is a projected curve. You'll find these features under Insert, Curve, Split Line, Projected, Composite, Curve, Helix, okay, whatnot. There is also one that's called an intersection curve, where you can take two planes, or a plane and a surface, or two surfaces, and get a curve at the intersection of those two entities. Now again, that's not really a curve feature, that's actually a 3D sketch feature. So SolidWorks sometimes confuses curve features with 3D sketches. Let me demonstrate a little bit for you. To start a helix, I'm going to start by sketching a circle. Okay, and from here I'll select the helix and spiral. Now there are a lot of different ways to specify the helix, and I'm going to come back to those, but what I want to show is that a curve feature is this thin blue entity. If I were to create a 3D sketch, then create a spline, okay, and we'll just put in a bunch of points around here like this, and we can go look at it in the third dimension and tug and pull. So this is a real 3D kind of potato chip entity. You can see the difference between a curve, which is very thin, and a 3D sketch, which is very thick. Now some of the 3D sketch entities that are going to look like curves or sound like curves are going to be the convert entities. Will actually create a sketch for you. There's the intersection curve, which we mentioned earlier, and this is really a 3D sketch rather than a curve. It's not very helpful that in some other CAD packages, splines are what are referred to as curves. It's just a little bit of a terminology glitch, and SolidWorks is very inconsistent in this way. So just be aware that there's a difference between a curve and something that may look and act like a curve, but it's really a 3D sketch. So let me just hide this 3D sketch, and let's go back to working with the helix. Now the helix is a very powerful tool. There's several ways that you can determine a helix. First is pitch and revolution. So you have to select two of these three: a pitch, revolution, and height. And so you can pick any two of those and determine your helix. Now pitch is the height between revolutions. So what that means is the distance from here to here in one revolution. Okay, so if I change the pitch, notice how it's getting shorter, because we're determining by pitch and revolution, and we've got only one revolution, so changing the pitch also changes the height. All right, so we can also control the number of revolutions, and SolidWorks allows you to control this by quarter of a revolution. You need to also be aware that there is a control over here called start angle, and this depends on where you've selected the initial circle that the helix is based on. So this really should default to 0 because most people don't know about this control, and most people don't use it. They just take whatever is given to them. The next thing I'd like to talk about here is the variable pitch. So when you do a variable pitch, you start to specify the helix in a chart format. You would say, oh, you need the pitch to be certain number of millimeters per revolution, and we can go down to say 100. And for how many revolutions do you want that to happen? Well, let's say 5. And you need to specify a diameter. So you can also have a variable diameter here. So you can tell it 400. And if we can get all of these things off the screen, it becomes very controllable. So we can go in here and tell this 10. Change this to something a little more drastic, like 50. So there we're getting a much tighter helix on this end. We could also change the diameter to something a little more drastic that's easier to see, such as 600. Okay, so now you can see that the helix tapers, gets closer together. Let's change back to constant pitch. You can tell it also, you could do a tapered helix. If you don't want to do the chart, you could just give it an angle. There's our 15 degree. We can taper it inward or outward. So anyway, just a lot of different ways to control the helix. Now, I want to mention this because a lot of people lose track of it. There's a spiral definition in here, and a spiral is really just a flattened helix that has a certain pitch. The pitch in this case is the distance from here to here. Okay, that's the definition of the spiral. So you can make them go clockwise or counterclockwise. The same is true with the regular helix. So if you're creating a left-handed thread or whatever, you could do that with the helix. Or a spiral is useful in some cases. I don't use it as frequently as I use the helix, but I do use spiral from time to time. Okay, now this shows up on the feature manager as a helix spiral, and in the graphics window, it shows up as a curve. That's very nice. Here's one other thing that I wanted to show you for curves, and let's use a couple of splines. Okay, now people don't always use splines, but I just want to demonstrate what's called a projected curve. Okay, so we've drawn this sine wave looking thing from the front plane point of view. Now from the top plane, I'm going to go back and use the spline again and make it like a C shape. So it's got a distinctive type of curvature from these two different views. Now, what a projected curve does is it takes these two curves, extrudes them through space, and it finds the intersection. So if I go to Insert, Curve, Projected, and when you do a projected curve, you can project a sketch onto a face, which I'm not doing here, or you could project a sketch onto another sketch. And that's what I'm doing. So you need to select two sketches. We'll do that here. And there's that check mark on the right mouse button. So I'll say OK. And so now I've created a curve that from one point of view looks like the sine wave, and from the other point of view looks like the C. And this is called a projected curve. Notice that both those original curves that I drew, or here I'm getting my terminology mixed up, but both of those original splines that I sketched are under here, and you can go back and edit these and flip convexity or change something if you want to do that. So it matters which one is shorter. So if I pull this one back, I delete that relationship there, I can pull this back like this, and that way my curve only goes that far, and it's not going to represent the entire sine wave. Okay, so it's really just going to do the shorter of the two curves. I could make this one extra long, and it will still only do the shorter of the two curves, which in this case is the sine wave. So in any case, that is the projected curve. I use that from time to time. It's probably the second most used after the helix or spiral. Next, let's take a look at the flex feature. Okay, to demonstrate the flex feature, I'm going to use this spoon, and this spoon has a couple of curves in it, as you might have seen. So the curves set up a sweep feature, and I'm not really here to show you how this one was modeled, but some of the things that we're talking about in the course of this video have been used here. Okay, so let's use the flex feature on this, and let's talk about what the flex feature is for. Let's go to Insert, Features, Flex. Okay, so the flex input is really just what body do you want to flex. So let's flex this body. What types of flex can we create? We can bend, twist, taper, or stretch. Flex is really the type of feature that you want to use for possibly a visual representation rather than a really detailed design type feature. If you want to design something that's bent, then design it bent. Don't use the flex to create the bend. Okay, I would use flex to make a pictorial representation of a bent spoon, or of a rubber port cover that's been pulled back, or one of several other things. But if you want to create a decorative feature that's something that's twisted, don't use flex to do it. Use a sweep to do something like that. And so you're actually designing something that's swept and twisted rather than using flex to do that. Okay, so the whole idea here is that SolidWorks is going to take whatever's between these two planes, and it's going to apply whatever process that you've put to it here. So you got trim plane 1 and trim plane 2. You can use various methods to locate these, but I'm just going to drag them here to get them positioned. And the fact that there's no selection here just means that you haven't created a parametric selection, such as a sketch point or a hard model point to place that plane. And from here, there's two different ways of bending it. You can give it an angle, or you can give it a radius. And remember, these two are going to work in opposite directions. So the bigger your angle is, the smaller your radius is going to be, and vice versa. Okay. So if you move this plane, then you notice that the bend changes because the area being deformed is slightly different. Okay. So we can change that now to twist. Notice now that the spoon is twisted, and here I can just apply an angle to it. And it's actually twisting the solid model. So it's making a change to the existing solid rather than creating something new. You can taper that, which gives you kind of a funny result. Okay, and or you can stretch it, which just means pulling it out a little bit and making it a little bit longer than it was. So those are the 4 modes of the flex tool. You use it for editing existing solids. It doesn't really create anything new. And I would use it for a looks like model only. I wouldn't use it for real design. Pictorial representation is pretty good, but you know, I wouldn't cut a mold based on geometry that I've used the flex feature for. Okay. So that's just a smattering of the secondary type features that you can create in SolidWorks. Thanks for watching.